Welcome everyone to IBM Z Datathon that we are bringing over to you in collaboration with Shooting Stars, and we being IBM Z. As you can see in the title, IBM Z Datathon. So we're really excited to be able to bring IBM Z as a technology, and specifically this ML on Z offering for students such as all of you here to be able to try your hand at coming up with a solution. And as you all know, the theme is tech for social good. So coming up with some social good issues that are close to your heart in your regions, and think about how you will be able to build a solution leveraging our IBM Z platform that we bring to you as part of your solution, right? And so today we have Joe Bostian and Alex Osachi, two of our resident experts on machine learning on Z. In fact, they are the masterminds behind putting this whole offering together. So without further ado, I'm going to let Joe and Alex introduce themselves. I believe Joe is going to go first. Pay close attention to all they have to share about data science in general, machine learning in general, and also specifically the instructions and the details for how you will get started with the ML on Z. Bring all of your questions, eager to answer your questions. And at the end of this session, you'll have instructions on how you can log on to those ZOS instances that Alex will talk about and walk you through. We'll be around here for up until 10 a.m., which is 10:30 in India. And so try it out and ask us if you have any questions. Look forward to all of your amazing solutions starting tomorrow. All righty. Over to you, Joe.
Okay, so let me share my screen. Hold on a second. Okay, can everyone see my presentation screen?
Yep. Yes, we can.
Yes.
Okay. So I'd like to begin today by just introducing the IBM Z platform and try to give a little bit of context as to why analytics and machine learning are important on this platform. Analytics workloads have always been important in the commercial world and increasingly in our everyday lives. And they are definitely a workload that we really care very much about on IBM Z. And so through your participation today, we hope that you can gain a little bit better understanding as to what we can do with this platform, how it might fit in with a larger AI ecosystem, regardless of whether that ecosystem exists on IBM Z or in conjunction with other cloud providers or perhaps other kinds of platforms. So I'd like to begin acknowledging a little bit about our history. Right? IBM Z is the platform that people often refer to as a mainframe. We generally like to refer to the platform as IBM Z today. Our platform is over 50 years old, and we have been continuously refining and upgrading to state-of-the-art levels of performance, efficiency, and scalability over the years, continuously, just so that we can continue to possess sort of that privileged place at the top of the enterprise IT heap. We have the best platform and the best hardware to go off and run these kinds of analytics workloads. So you may, when you hear the term mainframe, you may think of black and white photos of the way it used to be with a government agency in the 1950s, or perhaps a grainy color photo from the 1960s or 70s, where people talked about the mainframe growing up and becoming part of the IT floor, and even later on, where mainframes consumed giant IT floors and large areas that required a lot of heating and ventilating, required a lot of power. And these are often held up as the kinds of computing deployments now that aren't even as powerful as what you have in your mobile phone today. These are stepping stones and were levels of achievement that we've gained in our past. But today, this single machine here represents an entire mainframe. Everything that you saw in that previous photo is not nearly as powerful as this one single rack, which can do much more than any other platform that's really ever existed, including all of the ones that you hear about from the past. You can have these with a large number of CPUs. You can put 190 engines in them, 40 terabytes of data. I won't read through all of the statistics here, but you can look at them for your reference to see just how large these machines are. And you can take them and you can put them together in what we call sysplex arrangements, where you have multiple of these things and they can all talk to one another and behave as if they're a single unit. The point is that these are highly configurable. This does represent the state of the art in enterprise computing today. And it really is the platform where you want to do the kinds of AI processing that we are encouraging everyone to do during this datathon. So just a few usage statistics. Most of the world's top banks use mainframes. There are over $7 trillion worth of credit card payments that are processed every year. And so really, when you look at the financial sector, whether that be banking or insurance or government agencies or anything else that's involved with performing official transactions on behalf of whether an entity of some kind, whether that's, as I say, a government agency or a private company, there's generally a mainframe behind it to record that transaction and be what we call the system of record. It is the place where the transaction is recorded. There may be other indicators on other machines that say, yes, this transaction took place, but the mainframe is where the reference transaction actually takes place. So you can see there are billions of transactions that are processed every single day. Every time you go to an ATM, for instance, you will generate a transaction that occurs on a mainframe. So just to think about this a little more broadly, right? If you've never used a mainframe yourself personally, or laid your hands on a mainframe, or seen a modern IBM Z system today, you have interacted with one almost every day. If you pay your bills, if you surf the web and perform any kind of a transaction, if you buy anything at a big box retailer, or stay in a hotel, reserve a car, fly on a plane, any of these activities will result in a transaction occurring on a mainframe. You never get to see that because there are many layers of other computers and cloud providers that exist between the mainframe and you as an end user. Usually that will be through your phone, or perhaps it's through an ATM or a cash register at a store. But you can rest assured that when your transaction finally gets recorded, it almost certainly wound up on a mainframe somewhere. Okay, so we're all IBM Z users, even though we may not interact directly with them in a sort of hands-on fashion. What you'll be able to do, though, with this datathon is you will actually be able to run transactions. I won't say transactions. You'll be able to perform your AI workloads directly on an IBM Z with no intermediate providers in between. So that's really exciting. That's a very interesting thing to do, and we hope everybody really enjoys their efforts, through this datathon. A few things from a machine learning or an AI perspective. These are sort of big data themes. You hear the term big data thrown around a lot, and there's a lot of AI and machine learning terminology that is sort of wrapped around that as well. There are some themes that are very, very important to the industry as a whole and are really relevant to the IBM Z platform. The first one is this idea of data gravity. That is that you really should process your data or bring your workloads to the source of your data. A computation is much more efficient when it can be performed directly on a local data source. If you have to go to the network or to the web and rely on several different hops through the network to get to your data, number one, it takes much longer to access that data. And number two, any node in that chain that might be down could prevent you from performing the work that you need to do. If you're simply developing an application or you're trying some things out, perhaps that's an inconvenience. But if you're a business, that means that's your storefront, and your clients are now not able to reach you, and you're really impacted by that a great deal in a financial sense. Okay? So when the data especially is of a very large size, you oftentimes hear people who like to throw around terms exabytes and petabytes of data that exist, and how they can provide access to all of these vast quantities of data. That is true, perhaps, but nobody's moving exabytes and petabytes of data around the network. So the idea then is bring your application or your workload close to your data. It will run much better. It'll be much more stable and efficient. And there's lots of other things that you don't have to think about, like protecting that data. Okay. So if you think about data latency, there are what we call mission critical or enterprise critical timeframes in which things have to work. Increasingly, we're working with clients who say want to know if a certain credit card transaction is authentic or not, or if they're about to incur a fraudulent transaction. You can't tolerate data latency of more than say 30 to 50 milliseconds of time. So if you have a client, if you have a customer at a cash register trying to use their credit card, and you want to run an AI-based check to make sure and verify that this transaction is authentic, you don't have 3 or 4 or even 10 seconds to perform that verification. You have to do it within a 30 millisecond window in order to keep that person from becoming a dissatisfied customer. So data latency here is very, very important. The point here is, we always like this term in the middle of the slide here: the data lasts forever, but the insights are perishable. So when someone performs a transaction, you may gain an insight from an AI point of view from that transaction, but once that transaction becomes more than an hour old, it's not that important anymore. It is a historical fact, and you may need to reference it at some point in time, but in terms of the insight that you can gain into the client you're working with, it's of no benefit anymore. And lastly, and most importantly, especially on IBM Z, is data security. Increasingly, everyone is working with what we call personal sensitive information. Personally identifiable information makes the news all the time because people who don't take adequate care and manage that data securely often wind up inadvertently providing it to hackers or people who have bad intentions. And this almost isn't news anymore because it happens so frequently. So personal sensitive data is very, very important to take care of. And there's increasingly more and more regulation that imposes penalties for people who are careless with personal data. We take that very, very seriously in the IBM Z realm. And so we go and provide extensive infrastructure to help users of IBM Z keep that data private. And again, this comes back to the idea of data gravity. If you have your workload right next to your data source, it's very easy to keep that to be a private environment. If you have it spread out over an entire network, that data could be intercepted anywhere in that network, and now it's much more difficult to keep your personal private data that's actually private. I'd like to show a few high-level details of the environment that we're working in, and I will really try not to steal any of Alex's thunder going forward. This, at a very high level, is the environment that you'll be able to work with. There are several components that are out there. There is a layer called IBM Watson Machine Learning for ZOS. We generally are not encouraging people to use that, but instead work with the open data analytics for ZOS. You'll hear us refer to it as IZOTA sometimes. This has all of the componentry in it for you to write applications and workloads to go off and accomplish the work that you may need to do for the Datathon here. It has a component called Spark. For those who may be interested or know something about the Spark environment, you can use that. Generally speaking, we think most people will be interested in using the Jupyter environment and writing a Python application to perform that kind of work. Below these components within IZOTA are various what we call data access components. Generally speaking, there is a component here that will allow you to reach ZOS data sources that are native to the platform. This is the IBM Z operating system. And the optimized data layer would give you access to whatever resources you have on the platform. For the purposes of the Datathon, it can be a rather complex data access chore to go ahead and access the ZOS native data sources. So we generally encourage people to go to a common data source and perhaps bring your own CSV file or use an externally available open source like a social media stream or government provided open source data set. And then you can access those much more easily from the workloads and the applications that you may be putting together for this Datathon. So we encourage people to use Jupyter Notebooks. They're a great interface to use. You don't have to. Again, these are suggestions and not requirements. We would definitely suggest, though, to keep your data access very simple, right? If you have data in a simple form that's easy to import into a Python environment, and then you can actually run your workload from there, that is probably the most efficient way to move forward. And choose a data source that doesn't require a lot of what we call wrangling, right? A lot of times data has incomplete fields that are in it that have to be filled in that can break your computation or your workflow. And if you choose a data set that has all the values filled in that are all a very consistent form, you'll save yourself a lot of time and a lot of effort in just trying to fix problems with the data before you can run the workload. So those are just some suggestions given the limited time frame that we have, to move forward. So I'd just like to close with the overview with this kind of a photo here. I always like to tell the story of a colleague who was in Canada. I'm located in the United States, and my colleague is as well on the East Coast. And they were up in Canada performing either on a customer trip or on a vacation of some kind. And it was at the end of the week, and they were driving home, and they get to the border, and there's about a 2-mile traffic jam to get through the gate at the border. And she gets a phone call on her phone asking for help with a problem that turned out to be a bug in our IBM Z operating system. And so she tried to help people out, to debug the problem over the phone. And eventually they got enough information that they went forward and they tried to do some more problem determination. They figured out what the problem was and they fixed it. My colleague eventually made it through this very, very long traffic jam, only to find out that the reason for the traffic jam was that the Customs and Border Control were the people who experienced the problem that she had talked about on her phone. It just goes to illustrate the point. If you have a problem on your mainframe, the world in general has a very big problem. This platform is like no other. We don't simply just put web pages up and ask people to fill in forms so that we can gather data and do something with it. This really does run the economy in many of the governments around the world. And so we have to recognize the importance of IBM Z, even though it's not easy to see and to touch. It's important to know that it's there, and that this is a very, very important part of what we call the enterprise and computing ecosystems. So I'd just like to say good luck with all your efforts this weekend and throughout the Datathon. You're really working on a world-class premier platform. and we really strongly encourage you to stay engaged. There are open source organizations you can get involved with if you want to follow up. I will just put this up briefly on the screen. This is something called the Open Mainframe Project, and you can get in touch with many of us through the Open Mainframe Project in general if you want to follow up after the Datathon is over. So good luck with the Datathon. Certainly be engaged, and we'd be glad to continue conversations with you throughout the next few days and beyond. Okay, so thank you.
Hey, thank you, Joe. Yeah, really great, amazing introduction to IBM Z and history and all the modern things like AI and machine learning. Yeah, I'll take it from here and let me share my screen. All right, yeah, I'll take it from here and I will introduce
Alex,
you.
Stupid shit. Okay.
You good? All right.
Yeah, go ahead.
Yeah. Okay, I hope everyone can see my screen now. Yeah, we'll take it from here. We'll introduce you to the environment that we prepared for today's event. And I'm Alex Asachi. I'm solutions architect here with IBM, and specifically focusing on IBM Z. I work with partners, different software vendors, help them to build their modern applications on the platform. And there are a lot of new stuff going on IBM Z platform. You know, machine learning, AI is one side. IBM Z is also a key component in IBM's strategy for hybrid cloud. Yeah, we also have IBM Z machines in the public cloud as well, running HyperProtect services and recently also the VPC platforms. So yeah, today I'll walk you through the environment that we prepared, and also show some demos, and also will give you some maybe insights on how we will judge the submissions and point you to some data sources to help you succeed with your solutions. All right, and I'll start with the architecture of the system that we have prepared. And as Joe introduced, it's about the IBM Open Data Analytics for ZOS, or acronym IZODA. So we have IZODA deployed in our community, IBM Z Community Cloud. There are two parts to it. There is a front-end part that runs on Linux, and there is a backend part that runs the actual analytics engine, and it runs on ZOS. And Linux platform, right, in IBM Z these days can run both platforms, Linux, which is an open platform, and various open source workloads and familiar tools can be run on that part. And then there is a ZOS, which is a traditional Unix-based type of system that is highly optimized for transactional performance. And that's where the we run lots of machine learning, or in this case, IZODA with Anaconda, Python, Spark. You may be familiar with these popular open source tools. There are databases and data sources connected to it in the environment, such as, we have a DB2, which is a SQL database, and we have the VSAM, which is a data set, or you can think of it as a file type of system on ZOS. We also allow you to upload the CSV files, and it turns out CSV file is very popular, I think, among students, as it's probably the easiest way, and that's the format you usually find the files online. There are a few simple steps on how to sign up to the environment and how to then log in, access it, and run some sample applications. So at first you will log in. You'll log in, register following this link here. As I believe we will share the links in the Discord as well. Yeah, you will follow the link, you'll do the registration, fill in some basic information. After that, you'll receive an invitation email and you will be able to log in to the portal. Once you end, you will be accessing the dashboard, and in the dashboard, you will be able to configure your analytics instance, right? So each team gets one registration, one account, right? And you will get your own analytics instance. Even so, all instances are running on the same maybe machine, IBM Z machine, right? They are isolated. So each team gets their own analytics instance. There are some restrictions like for the password and data size, and I'll have a few more slides later for those common issues. We have prepared 3 samples, which is one is a Python program with Jupyter notebooks. And yeah, I'll demonstrate that one specifically more in detail. There is also PySpark, right? So when you're looking into kind of production areas, then you would definitely want to have something which can distribute the model processing across multiple instances, and that's where the PySpark comes in handy. We also have a Scala example, and that one shows you how to maybe leverage and how to process models in the batch mode. After that, yeah, once you try out one or all 3 use cases, you can proceed with developing your solution, right, in the same environment. And yeah, from here, let me switch to browser. Yeah, we have in an open GitHub, we have all the sample files here, those Jupyter notebooks, and also a comprehensive detailed instruction. It also has the same architecture diagram I showed with steps where you will be able to sign up with the login. You will select the tile for analytics. You'll get to the dashboard, and it also describes you how to, for example, upload the files, different type of files, or format of the files that you might have your data in. How you will also upload the Jupyter notebooks to the Jupyter file manager, run the sample applications. So yeah, pretty comprehensive documentation. And let me show my instance here. So here you can see I'm logged in as you know to my own dashboard, my own instance. And the first thing I did, right, I needed to set the password. So I had to change the password here. And you know, it follows some restrictions, like it has to be under 8 characters. My specific ZOS instance, right, has an IP address, and it's a private network, so you won't be able to access it from the public internet. But you will need this IP address, for example, later for the Spark to configure in your Spark notebook. And it shows that my instance is okay, running. I started it; it's active. I uploaded some files. We pre-uploaded for the demo. We pre-uploaded files already, so you may not need to do it for the demo. But yeah, if you have your own, you start your own notebook, then you will need to, for example, CSV, or yeah, if you have vSAM or DB2 is also supported. After that, you would just click on the Jupyter button, and it will take you to the Jupyter file manager, right? As you can see, I uploaded these 2 files with the demo, which I basically got from the GitHub here, right? You can see these are the Jupyter notebooks, and there is also the Scala demo. So yeah, I uploaded them to the Jupyter instance, right? As you can see, this is a Jupyter instance we prepared in the Z Community Cloud here. And I executed those notebooks already, just for the sake of time. So let me just walk you through one of the demos we have, which is the demo in Python, right? And what it does, it shows you how you can do some analytics and predictions on client retention using Python, using some machine learning. And also some popular libraries, which are also available on IBM Z, right? So in this demo, yeah, we'll use how you can access data from VSAM and DB2. And the data which is available for this demo, we have 6,000 rows of customer information. And also there is 20,000 rows of the DB2 transactional data, right? So the data is then transformed and joined in pandas data frames, which then is used to do some exploratory analytics. And then we'll apply a random forest algorithm to predict the customer churn, right? That's where, we're trying to see, like, let's say if we have transactional data, how customers using their cards, credit cards, whether we can predict customer loyalty or retention aspect of it. And yeah, the first step, like after you upload the Jupyter notebook sample, you will have to provide a username and password for your ZOS instance, right? Which is what you get here, right? That's your username of the ZOS instance, and the password, the one you will set here. You'll put it in the first step of the Jupyter notebook here to initialize the variables. Then the do the imports here of pandas and NumPy. The next step would be here, we will set up the mainframe data connections. And that's where the data from VSAM and DB2 will be loaded, right? If you use in CSV file, then yeah, you would just use the file operators of Python. The credit card transaction information is loaded into pandas data frame, right? We can see it here. And it's a typical credit card transaction data. There is some timestamps, there are some IDs, and which card was used. And then, of course, the important part, which is the amount, right? Transaction amount. We also load the client data. And the client data just has some basic information about the customer, right? The user of the card, such as gender, age, highest education, investments, income, activity level. And then we have also, as a reference, we have whether the specific customer churn or didn't churn, right? So we'll need this column to train the model later. So it's important to have that as a reference point as well. Before we can do even exploratory analytics, we should consolidate the data, or kind of pre-process the data, make sure that it's uniform, right, and ready to be consumed by the analytics or machine learning. And that's where we do some aggregate statistics, attach additional columns. For example, you want to have like an average transaction volumes per day, total transaction amounts, information like that. After that, right, we start exploring the data, right, in order to build the model, right? So you need to understand which features are the most influential, which features are relevant to the outcome, which we're trying to maybe model or predict. And that's where we want to do exploratory analytics. There are many features, right? So we want to actually look into them, visualize them, and see like which of those are the ones which are important to us, right? And at first, we're going to look into the annual income and age of the customer, right? And for that, we just build a scatter plot to see if there is, visually we can see if there is any impact from the annual income or age. And that's the distribution we see for these. Then we start looking into correlations, right? And here, maybe we put in different features and we try to see if there is any correlation between them. And in our case, I think what we are interested is in the result, right? Which is the churn, like whether customer did churn or did not. And we want to see like which other features correlate with the churn, right? And we of course want to see maybe the anti-correlation or negative correlation in this case. And if you look at the churn row here, you will see that we have a high negative number for the age feature, right? And we have the high negative correlation for the activity level, right? So these two seems like are important features for us to be able to model, predict the churn, customer churn. So now, as we know those two, we picked those two features, important features. We want to again visualize them, and we're going to use the histograms, two histograms, and we will look into, for example, first the age, and see which, depending on the age, whether customers did churn or did not churn, right? So the green one shows maybe that there is a higher churn in the younger age people, maybe less churn in everybody else. Then we probably want to look and see how we can combine it, the age, with another important features, which is the activity level, right? And for that, we're going to use the slot chart, box plot chart, where we put both, we put the age and we put the activity level into perspective. And then we're looking at two green ones that didn't churn and the blue one that didn't churn. And here, as you can see, again, it gives like some insights into, okay, we have the low activity level, maybe younger age, it's mostly green. Maybe we have higher level of activity, it's mostly blue. So we kind of getting an idea like how these features influence the outcome, the churn rate. Yeah, another useful chart for visualization is the bee swarm, right? That's where instead of the boxes, we can see the actual dots, right? So we can see it more granularly. And that's again a similar relation we show here in this chart, where we have the age, activity, and then did churn or did not churn. So now as we got an idea of this, we start training the model. And for the model, we're picking the random forest algorithm. And there is an sklearn libraries which are available to the instance. So we create the, we prepare the data, we initialize the model, we split the data sets. Some jump here. And then we do the training based on the training data set. We do the train the model. Yeah, after that, once the model is trained, we want to kind of leverage this model and maybe use the try to predict not only whether the specific customer will churn or not churn at some point. We also want to maybe be more proactive and see if even maybe at the point of credit card application, if we can already tell, right, and see what would be the business loss or profit of specific customer applying for credit card, right? And that's where we try to leverage the model what it created, right? And we'll look into, we augment it with the predictable transactions and the volumes, right? And we are able to tell now, based on the age, for example, of the customer that is signing up, right? Whether will be profitable or will be at loss, right? And here is the predicted loss. After we run the model, we can see the predicted loss, right, by the age, for example, right? And it kind of shows us. So based on this now, right, we can basically provide the leverage machine learning in the maybe credit card application module and be able to help the people who are processing those applications to make decisions based on the model, whether to approve or decline a specific credit card application. Okay, get back to the presentation here now. Okay, so you will be able to run the same Python Jupyter Notebook as I demonstrated, right? All the data is available in GitHub, so you should be able to get the notebook itself and the data and run it. There are also PySpark, right? A similar demo we have for the PySpark, and then Scala. You can also try those as well. One important aspect, so during the registration, when you signing up for your Teams account, we want to ask you to specify your team name and the number in the description field. Right, so when you sign up, you will feel like your name, contact information, and so on. But there will be also a description of your project field. So yeah, please make sure you provide your team name and the number here. Then speaking of the judging criteria, right? So once you create your solution, you will submit it, and those submissions will be then evaluated by our judges based on several criteria. And here we'll be looking like on one side of the scale, right? We'll be looking into how novel your solution, how relevant it is, how practical, right? But on the other side, of course, we'll look into how do you leverage IBM Z, right? Does your architecture position machine learning, analytics data on IBM Z platform? Have you tried the actual lab environment which we provided, right? Have you tried those samples? Have you built something by yourself and ran it in that environment? Yeah, perhaps you would not like run the entire solution IBM Z in the lab, but try some parts of it, right? And you kind of do some POCs, proof of concepts for that. And yeah, all these factors, right, will be weighed in, and the judges will, judge your submissions based on them. Yeah, there is a short list of frequently asked questions and problems, like we experience maybe some users, some people run into. And the first one is, if like after you upload, let's say you use the dashboard to upload some CSV files, how can you get a list of those files? How can you see that which files are there on the IBM Z system, right, on ZOS? And yeah, to do that in Jupyter Notebooks, you would simply import the glob library and then just use the print to output the list of the CSV files here. Another frequently asked question is, where can I see the list of packages, right? And that's the GitHub link, the same GitHub repository that was mentioned earlier. Or another option, of course, if you're familiar with the pip library, you can just run that library and yeah, get the installed packages. Yeah, there's a note. This is a lab environment, so we don't frequently update it. So there's some libraries that may be outdated, right? So yeah, please be aware of that. Another question that comes up is, how can I upload the data and what are the formats requirements? And yeah, again, dashboard, that's where you can upload your files. We support CSV, DB2, and VSAM. The maximum file size is 200 megabyte. And something to note here is, if your file is larger than 100, then there is an upload indicator, and that indicator kind of disappears after some time. So yeah, in this case, if you have this larger file and you don't see if it's uploaded or not, you would use the Python code and later to check if the file is uploaded. But yeah, in general, since these are lab instances, they're smaller instances, right? So we kind of encourage you not to use like larger data sets, maybe try to keep it under 10,000 records, just to make sure that your model runs faster, that you don't really overload the instance and wait for the responses like minutes and hours, or maybe at some point it may even lock up. Change password, right? So if it doesn't work on you, most probably it's because you're trying to use more than 8 characters, and the password has to be alphanumeric. You cannot use any other characters there, up to 8. If you're running, you're processing the data set, and then it takes a long time, and then at some point it errors out, then again, most probably it's a problem with that you're using data set which is too big, right? So the lab instance, they have limited amount of RAM memory allocated, so you may easily run out of memory if you kind of keep multiple copies of the data. You upload a huge data set, and then you just as you transform, you create multiple copies in the memory, right? So try to stop and start the instance in this case, right? And if it still doesn't help, right, then probably the fastest way would be to create another instance in this case, right? So feel free to reach out to us, to IBM SMEs, who will be supporting, right? If we cannot help, then yeah, you would need to probably create another team account and get another instance for that, so that you're able to proceed. Here are a few suggestions now on where to source the data. And I think the one big source, many of you may be already familiar, is kaggle.com, right? It has a huge amount of public data sets for machine learning. Could be used. There is a data.gov, and yeah, in US, the government organizations, they are required to provide all of its data to the public, right? And that's what they use to publish them. Their data sets, to share their data sets. There are some other useful data published by specific agencies like US Bureau of Labor Statistics or Federal Reserve. Universities, some universities, they also publish their data sets, such as UCI or UC Davis. COVID, right, is very popular topic these days in terms of data and research, and also like amount of different data available. So you can look into CDC data. There are also vaccination records by countries available, different hospital resources information, mental and medical information as well available, which could be analyzed, right? So it's up to you, like which area you decide, and then I'm sure there will be data sets available for you to make a use of it to create the model and be able to complete your project. All right, and this basically concludes my part here. So definitely thank you everybody for attention, and wish you best luck with your projects and submissions. And yeah, there will be IBMers helping you along the way. Yeah, if any questions, feel free. I'll be also in Discord available some hours. So yeah, feel free to reach out to us if there are any questions. We'll be happy to help.
Hey Alex, there was one question about the availability of Git in this environment. Will people be able, for instance, to do a Git clone directly into the environment, or will we have to FTP like tar files into the environment before using them?
Yeah, the environment itself is isolated, right? So it runs on our private network. So we don't provide underlying access like the OS level access. You want to be able to get to Bash or ZOS terminal. But yeah, the only interface you have, right, is the front end through the Jupyter, right, which kind of limits you to the Jupyter interface, and also, the Jupyter Notebook code that you can run. Yeah, and yeah, I know sometimes the questions come up whether we can run any like a web server, a Flask or something, and yeah, the answer is basically no, because again, this is a limited lab environment. So mostly we want you to use it to focus on machine learning and Z, right? To try it out, to experience, maybe to do some proof of concepts. And yeah, the actual solution, could be, could be running anywhere, including your local maybe laptops. Yeah, as long as you kind of leverage and focus on Z and try it out and do some proof of concept there. Yeah, that is already a good achievement. All right, so then no other questions or
Alex, another comment. So
okay, sure.
So we can't clone any repository, I suppose.
No, you cannot. Yeah, not onto the environment, right? So you can clone the repository, our repository, right, which we have with samples onto your local machine, maybe local computer, and then upload those sample Jupyter notebooks to the environment, to the Z environment using Jupyter interface. But you won't be able to clone onto the environment directly using Git.
Excellent, thank you. And I guess another question is, will the students have access to the recording after this meeting for reference later? Shooting Stars team, do you want to take that?
Absolutely, you'll have the recording. So the recording is also available on YouTube. We will share the links with you.
All right, thank you. Yes, and for the PowerPoint, I guess, yeah, Alex, are we able to share this deck, Alex and Joe, with the students?
Yeah, we should be able to.
Yeah,
I
sure,
guess
of course.
If there is a location, right? So yeah, you can post it.
Excellent. Yeah, I guess we can share it with Abhi ahead of him sending the Zoom recording, so that the Zoom recording link and the deck can go together to the students.
Absolutely.
Sounds good. All right. Another question. What if we have image data and it clearly exceeds the data limit? I wish. I wish our Unfeel the Burn team were here. Right, Alex, you want to take that?
Yeah, sure. Yeah, and yes, this is a limited, again, lab with limited resources, right? We have, and again, each team gets their own instance, right? So you can imagine how many instances resources we actually leveraging in total. To be considered that, right? So yeah, see if you can, and that's maybe also like in general, the good practice, right, is to downscale your data, right, for the analytics, because yeah, you don't want to, if you use larger images, right, or bigger data sets, right, it takes longer to even train model, right? And then while you're experimenting, you maybe try and applying this algorithm, that algorithm, right? You don't necessarily want to wait, hours for the model to run in order just to, to do one test. And then, if you need to do like tens and hundreds of different tests and mock different models, right, it will take forever. So that's where, yeah, in general, yeah, I would recommend, to downscale your images, use a smaller data sets to initially to experiment, right, to do the modeling. All right. Any other questions?
Alex, I am just trying to reiterate, on chat as well, the sort of basic rules that each team just has one instance. So one team member signs up for one ZOS instance for the team. And as you had pointed out, when you sign up in the project description, please put in your team name and team number. That'll help us know that, the teams are all there. And if you have any issues, then we are also able to look that up in the backend system. Password rules, no more than 8 alphanumeric characters, right? Because Again, we're all used to putting all sorts of characters in our passwords and stuff. Please don't do any of that. Purely alphanumeric, no more than 8 characters long. And for the data limit, Alex, do you want to go over that just one more time? I just want to make sure all of the, because that is where we've seen some of our ZOSs stall, which is when students, when the teams upload a very large data file. So I just want to be aware, make sure the students are aware of a limit there. 100 megabytes, no more than 100 megabytes per file. Yes?
Yes, that is correct. 100 megabyte, right? There is a way to get more than that, like up to 200. But again, the larger the data set, you know, the more processing time will take, and there are more chances that you will run out of resources, because again, depends on your code, of course. But yeah, if you, let's say, loading it into the data frames, and then you make copies of that data, just, you know, transform it, maybe augment it, and then you make copies and copies, right? Then you will run quickly out of memory.
Yep, exactly. And in a recent event, another team that sort of tripped was the file size was small, but it's just the number of rows were huge. I want to say in the order of hundreds of thousands of rows. And that sort of stalled their ZOS as well. And they came up creatively with a way to continue their work and were one of the winning teams nonetheless. But I just want to caution the team. So when you get your data set and it's a CSV file you want to upload, try not to keep it more than a few thousand rows of data. Alex, Joe, thoughts on that?
Yeah, it's as long as you keep in mind that we're in a lab environment and not like a production environment. Clearly, you know, there are limitations that we'll all have to live with here for the datathon that we wouldn't otherwise accept, you know, in the open environment. But we are trying to accommodate a lot of teams on a limited set of resources. So we realize that in terms of the amount of data you can process, 100 megabytes really isn't very much at all. But what we're really trying to do is have a large enough data set that you can illustrate your workload, demonstrate how it works, and that's enough, right? We wish we could provide, you know, much larger sets of resources, but we just can't given a number of teams.
Thank you, Joe. I don't see any other questions at this time. Oh, there is one question. Can we use Kaggle API to access data? Oh, okay. You already answered that, Joe. Thank you.
Yep.
Yep, sounds good. So bring on your creativity. You have a piece of a real IBM Z at your hands for this weekend. What we'd like to see is the magic you can create with your creativity. So looking forward to it very eagerly. Thank you, teams.
Absolutely. And before we leave, we have a few next steps that we want to discuss.
Before that, Abhi, there's one more question by Malay. He's asking, what do we have to like submit at the end? PPT or zip it a notebook or a Word file with all the information? What exactly do the teams have to submit?
Yeah, Akansha, would you like to take that?
So yeah.
Yeah,
go ahead.
I think Joe can answer that better.
Okay. Really, you can give us whatever it is the team thinks is appropriate to let us know what your solution is, right? We can handle a PowerPoint or a PDF or your Jupyter notebook. All of it's valid, right? You know, screen captures, videos, you know, little demonstration clips, any of that kind of stuff is fine. We've worked with a lot of stuff, but just make sure that you provide enough information in whatever form you want, you know, to give us a good, clear picture as to what your solution is.
Abhi, do you want to talk about, is the teams going to still submit using DevPost? I thought maybe that would be the next steps you would share.
Yes, yes. So let me share my screen, and I think
Okay.
I'm sure everybody would have a few more questions around submissions, the judging criteria. I know we discussed judging criteria, but the timings to submit the things like that. Right? So we have four key next steps for you, and these next steps will help you guide around your questions. The first is after this call ends, we will be sending you a pre-event survey. Right? Make sure that you fill that survey. We need some information about you, and we plan to capture that information through the service. So look out for your emails and Discord, and once you get it, do fill it out. The second thing and the most important thing is the Datathon guide. We will again be sending it to you after this event. This guide has everything that you need to know about this Datathon, right? How do you submit your ideas? What is the judging criteria? What are the rules, FAQs? I'll give you a quick overview of it too, but make sure that all of you go through this guide, and this will have most of your questions. If you still have any questions, reach out to the team on the Discord. Also to mention, we have a keynote tomorrow. We have exciting speakers. I think one of our star speakers this year is Tanmay Bakshi, and I think most of you already know about him. So he's a celeb. So he's an 18-year-old celeb. So Darshana, do you want to talk a little more about him?
Sure, just not to give away too much, but Tanmay will be sharing about AI and ML, and more importantly, about a really exciting project that he worked on that brings Z into his solution. So with that, come check it out tomorrow.
Absolutely. So very excited for this session. And so the hackathon, the Datathon starts tomorrow, September 25th. To make sure that you join by 7:15 p.m. India time and 6:45 a.m. Pacific time. And this is 15 minutes before the keynote starts. Let us know if you have any questions, and all the very best.
So Abhi, for the submissions, do the teams have access to DevPost? Is that where they will share their code? Because I do see another question that came to me about, will they need to present their solutions? Are they going to do a small video that they have to upload along with their code as their final sort of entry for their solutions?
Sure. So all of this is covered in the Datathon guide, but I'll give you some quick ideas. So the judging will be done offline. So what you have to do is register on DevPost. You have the exact steps in the Datathon guide. Register the DevPost with your team and submit your solution. We would love to see a quick video of your solution. You pitching the idea, a 3-minute long video. And your code, right? The code could be in form of zip or GitHub repository. Akanksha, let me know if I'm missing anything.
Yeah, that's what we need. And we have mentioned almost everything in the Datathon guide that we'll be sharing via mail today. So yeah, if participants have any question, they can ask us on Discord.
Absolutely.
And I see one final question that came through also about training models on CPU only, no CUDA device available, just to confirm, Joe, Alex?
Yeah, that's correct. There are no data accelerator engines. So there's no NVIDIA proprietary CUDA engines available.
All right. Thank you, Joe.
Thank you, Joe. Thank you, Alex. Thank you, Sudarshana. This session was very insightful and informational. Yep, I think most questions is answered. If you still have questions, feel free to reach out to us or the team on the Discord. A lot of mentors from IBM and SSF are there to help you.
Yeah, and one last thing I want to leave the teams with is we did this session here this morning, or rather evening in India and Africa, is so that we can have the teams start to sign up and get registered on the system. So go ahead and give that registration process a try. Please pay close attention to the process and follow and get registered. And if you run into any issues during the sign up process, if you'd let us know on Discord, our team can help you with any issues and resolving issues on the back end with the system. So that's the whole goal. So please go ahead and try and get signed up before our keynote tomorrow morning.
Absolutely.
All right, that's all I have. Thank you so much, everyone. Looking forward to all of your solutions and entries and how you come up with using IBM Z, and would love to hear about your experience through all of it, most importantly. Thanks.
Thank you, everyone.
Bye.
Bye.
Thank you, everyone.
Thank you.
Thank you,
Bye.
everyone. Bye.